Hi. In this video, we're going to be looking at the work worksheet and solutions to it. All right. So if you look off initially, we had talking about Amy uses 20 units of force to push the lawnmower 10 meters. And so on all of these, we're talking about work done. So work done, remember, is equal to the force times the displacement. Okay. And we did talk about it a little bit in the Nearpod, but the force must be parallel to the displacement. If not, we have to break it up into pieces, and so we're only going to use the parallel components. So we'll talk about that a little later on. But just keep in mind that the force and the displacement have to be parallel to each other. So talking about Amy using 20 newtons of force, so the force is 20 newtons, and she's going to push that lawnmower 10 meters. How much work does she do? Well, remember work, force times displacement, so the 20 newtons times the 10 meters will give you a whopping 200. And of course, our unit is Newton meters or joules. All right, next one. How much work does an elephant do when moving a circus wagon 20 meters with pulling force of 200 newtons? So we know the force, 200 newtons. We know the displacement is going to be 20 meters. So work done, force times displacement, is going to be the 200 newtons times the 20 meters to give us 4,000 joules. Next one up, a 900 mountain climber scales a 100-meter cliff. By how much work is done, or how much work is done by the mountain climber? So here the force applied is going to be 900 newtons because the mountain climber is going to have to overcome the force of gravity. And the distance, or displacement, is going to go is 100 meters. So for this one, again, work done is force times the displacement. So we're going to go 900 newtons times the 100 meters, and that in turn is going to give us 90,000 joules. Okay. Number 4, Sean uses 45 newtons of force to stop the cart 1 meter from running his foot over. Okay. How much work does he do? Well, we know the force applied is going to be the 45 newtons, and he applies that force over a displacement or a distance of 1 meter. So looking for how much work we do, that's going to be that force of 45 over a distance, and that looks more like a W, there we go, times distance of 1 meter, so 45 joules. Perfect. Next one, how much work is done when the force of 33 newtons pulls a wagon 13 meters? So again, guessing it out here, force is 33 newtons. Distance and displacement is 13 meters. Work done, force times displacement, so 33 newtons. I don't know why I'm having issues with my newtons today. 13 meters. And so when I multiply that together, I'm going to get 429 joules. I had to double check my math. All right, next one, how much work is required to pull a sled 5 meters? So we know the displacement is 5 meters. And we're going to exert a force of 60 newtons. So the work done, force times displacement. So we've got 60 newtons times the 5 meters, and that's going to give us 300 joules. Okay. Number 7, Tommy just 15 joules of work. Oh, so now we have something a little different here. Now we're giving the work the 15 joules, and we know the distance is going to be 1 meter, and we're looking for the force. So we're still going to use the same equation. W is equal to F times D, but our work done is now 15 joules. The force is what we're looking for, and our distance is 1 meter. So 15 divided by 1, so the force is going to be 15 newtons. All right, Angela uses a force of 25 newtons to lift her grocery bag while doing 50 joules of work. So we know the force applied is 25 newtons. The work done is 50 joules, and we're looking for the distance. Same equation. W is equal to FD. So our W is 50 joules. Our force, 25 newtons. And the distance, that's what I'm looking for. So I'm going to divide the 50 by the 25. So the distance she raises that grocery bag is 2 meters. So about 6 feet. That's, Angela's kind of tall. And lastly, the baseball player does 1,234 joules of work when hitting a baseball into left field. Assuming the baseball line is 100 meters away, how much force did the player use? So we know the work done. 1, 2, 3, 4 joules. And we know the distance it went, or displacement was 100 meters. So if we want to find that force applied, we're going to use the same equation. Erase that. The work done is force times displacement, so 1,234 joules is equal to the force applied times the distance of 100 meters. So our force is going to equal 12.34 newtons, which does not seem like a lot. It must have been a really, really tiny ball. So hope that helped. We got a lot of overkill. You know, 1 through 6 were all the exact same way, but hopefully 7, 8, and 9 gave you a couple of ideas on how to do things a little bit differently. And again, as always, if you have any questions, come see me. All right, have a great day. Bye.